Perfect. Okay. Hello, my kako. Thanks for inviting me. It's Kawika Winter. I think I know almost everybody here. But happy to wanted to come out and share some ideas that we are thinking about in Heʻeia about restoring the reefs out there. So I get into it. So I am the director of the Heʻeia National Estuarine Research Reserve, and apologies for the colorblind people on the call, but you will see we're located in the ahupua of Heʻeia. In orange here, we have the boundaries of the ahupua'a, and in yellow, we have the boundaries of the National Estuarine Research Reserve that was designated there in 2017 in partnership with the Native Hawaiian community. Excuse me, that is represented by the Ko'olau Poko Hawaiian Civic Club, the Ko'olau Foundation, Paipai o He'eia, Kako'oiwi, and on the government side, we have UH as the administering entity. We also have DLNR as a partner and Hawaii Community Development Authority as a partner, and the funding comes through NOAA. So it's a co-management endeavor, basically trying to help restore the ahupua'a. So we have four pillars of our program. We have stewardship, research, education, and policy engagement, all leveraged towards supporting the community of He'eia in ahupua'a restoration. So you'll note that within the yellow polygon over there, which is the NERR boundaries, there are a lot of what we call patch reefs. So generally, the way we describe the reefs out in this side of Oahu, we have fringing reefs that go away from the land. Then we have the barrier reef all the way on the outside, and in between, we have little patch reefs. And He'eia as an ahupua'a has a lot. So not so surprising that there is that famous saying of He'eia that goes Ke ko'a moku moku o He'eia, referring to all these patch reefs. So if I go up to Pali Lookout, you look down, those are the patch reefs that you see. Um, so one of the more infamous things that's happened in the 20th century was the dredging that happened in Kaneohe Bay, actually starting in 1939, but going through the majority of the 40s. The dredging was done initially because the military base out at Mokapu needed to expand their airstrip so the bigger planes could fly in. So they had to dredge reefs to get material to make that airstrip longer. Also, in that period, they were dredging reefs to fill in fish ponds in the bay, and which paved the way for development and other things. But so pictured here on the left, we have a picture from 1921, and pictured on the right is an aerial from 2021, so 100 years apart. So the picture on the left is pre-dredging, and you can see that there are entire patch reefs that are completely gone because of the dredging, and then there's other ones that were kind of shaved off. Either the tops were shaved off or the sides were shaved off, but you can kind of still see the remnants of some of those. So obviously, this dredging caused a lot of ecological damage, but understandably, a lot of negative impact to the indigenous food system. It made it harder for the people of this place to feed themselves. So that's kind of one little foundational element of what we've been thinking. And then I have a graduate student, Sarah Wu, pictured here, who has been doing interviews with fishing families because there's been a lot of talk of reef restoration in Hawaii. That talk has been dominated by conservationists and coral biologists. Not too many Native Hawaiian voices in those conversations. Not too many Lawaiʻa families have an opportunity or have been invited to contribute to those conversations. So she really wanted to focus her PhD research on getting Native Hawaiian and local Ohana perspectives on what a healthy reef looks like in Kaneohe Bay. And understandably, as you can all imagine, in the process of talking with the Lawaiʻa families, they're going to be talking about the stuff that they don't see anymore. And across the board, resoundingly, they've all talked about how there's no more lobster. We all used to eat lobster. Now we don't eat lobster. Even like, for example, Hi'ile Cavello, who I'm sure you all know and love. she was saying, the last time I got lobster was 25 years ago. It was right after high school. Me and my dad got lobster. I'm like, well, that was 30 years ago, but who's counting? But no, no. So it's been that long since lobster was abundant enough where Heʻeia, who dives all the time, could get. And this is something all the families are recognizing. So seems like if we're going to be doing reef restoration, lobster should be a focal point of the conversation about making sure there's more of. So that's just a little piece of information we have out there. But in general, aina-based restoration has been working well in Heʻeia. The Kakauiwi has been restoring the lo'i, pictured here on the left, and then Paipai o Heʻeia has been restoring the fish pond, pictured on the right. But if we want to think about are there any aina-based practices that extend out into the bay that can inform how we could restore dredge reef? So that's one of the questions we've been thinking about. Are there aina-based practices that can inform how we approach reef restoration? So then, A'ali'i Kelling, who born and raised in Ahupua'a of Heʻeia, went to Kamakau School, then went off to UH Hilo in their marine science program, got a bachelor's degree, then wanted to get a master's degree, wanted to come back home, see what is going on in his own community. And just as he was looking for a graduate program, we were looking for a graduate student to do some research on imu out in Haena. So this is on the island of Kauai. You may have seen in the April-May issue of Hanaho, there's an article on the work that we're doing out in Haena on imu. But basically, in Haena, Uncle Tommy Hashimoto, who I was close with the last decade of his life while I was there, he would always, I'd go fishing with him and he'd be teaching me the reef names. And we walked by this particular place called Koya. And he would tell me the story of, this is where Kalei would make imu. Kalei is one of the three of the last kupuna who were practitioners of the Oahi ceremony. So it was Hailama, who was Leiwan's great-grandfather, Kalei who is Noa Ka'amoana's great-grandfather, and then La'amaikahiki Mahuiki, who, if you folks know Uncle Moku, Auntie Lahela, that's their grandfather. So those are the last three practitioners. Kalei was one of them, and this place called Koya and was a boulder strewn area that he would make imu. And so Uncle Tommy Hashimoto, who is probably a young boy in the 40s, remember seeing Kalei making imu in this area. But then the 1946 tidal wave came in. Nobody saw Kalei after that. So that kupuna was lost in the tidal wave. And ever since he was gone, nobody was making imu in this place. But Uncle Tommy remembered seeing him and shared with me the story. So it was about 2010. I had a pipes intern who was from the marine science program, is Kaia Arataya. And young Kaia wanted to do a project out in the ocean. I said, well, we got this mo'olelo of imu that maybe we should try and bring that back. And I'd heard mo'olelo about imu or these fish houses from other kupuna that I was close with, like Anakala Erika Na'ana. Excuse me, but I never really was taught how to make one. But in my mind, when I kind of remember the stories that Anakala Eri would tell me, I imagine them being kind of like hollow pyramid style structures, but I wasn't really sure. So, and Uncle Tommy never shared with me what the imu and haena look like. So I'll just say, well, let's try. Let's maybe for your pipes project for the summer, let's imagine how many different shapes could an emu be in the ocean. So we imagine, pictured here, hollow pyramid, but we said, oh, we could also make just like an open ceiling donut, just like a circle of rocks out in the ocean, or we could make a tunnel. We could line up a bunch of rocks, two sides, and put a bunch of capstones. So that's what we did. So Kai'a's summer project was to do 3 iterations. We did the open ceiling donut in varying depths from super shallow all the way out. And then we did the hollow pyramid, shallow to deep, and then we did the tunnels, shallow to deep. And it wasn't the best science, but it was just a summer pipes project, and it was cool. But what we learned was the different shapes attracted different fishes. So the open ceiling donuts, we got a lot of hinalea. And in the hollow pyramids, like the one pictured here, we got a lot of manini, which is what matched up with the stories that I heard from Anakala Eddie. So that made sense. And in the tunnels, we got a lot of kumu, ahole hole, and lobster. So anyway, that was like a 2010 study. It was fun. But so now that I'm at Hawaii Institute of Marine Biology, and I go out and I do my thing, I give talks, and I talk about these AINA-based practices that build abundance in our reefs. So everybody has some familiarity with fish ponds, so it's kind of common sense now. Nobody questions that. But I was also talking about this practice of building fish houses and how that would build abundance in the reefs. But then I got challenged by some of my colleagues at the Hawaii Institute of Marine Biology saying, well, how you know that those are building abundance? Like, because common sense, what do you mean? How? And their point was, you're a scientist, you're talking about building abundance. Where's the data that you're basing these statements on? Which is, scientifically, that's a totally valid critique. So I'm like, hey, you want the numbers, I can get the numbers. So we got a grant, and we're looking for a student to actually do this work to see if the emus would build abundance in the reef. I'm not going to get into the whole research design, but after 2 years of a super robust study, clearly these things are building abundance of the fishes. So anyway, he was doing that study, but tangentially, we weren't thinking about lobsters. But what we found was within 2 to 3 weeks of building an emu, lobsters would make a house in these things. So not as much as had in the tunnels, but even in these hollow pyramid structures, they became lobster. These fish houses also became lobster houses. Like, oh, that's pretty cool. But we didn't really think much of it at the time, other than, well, that's a really cool little thing I didn't know about. So then that's like an aside. But now that I'm at the Hawaii Institute of Marine Biology, this is not a project that I am involved in, but some colleagues of mine out at Hawaii Institute of Marine Biology got a huge grant from DARPA. So DARPA is the military funding. They fund all kind crazy new weapon technologies, but they also fund things that will, there's a line of funding to protect coastal military installations against sea level rise. So they put out a big RFP. They wanted some researchers to design a structure that would take out 90% of the wave energy, but would also be a reef that would grow with sea level rise. So it's not just a pile of concrete out in the ocean, but a structure out in the ocean that will grow. And so this is a project that my colleagues put together. There's kind of like a barrier reef structures and then some patch reef structures. So they're all puka puka. That's kind of like when you throw a wiffle ball, you actually can't throw it that hard because of all the turbulence you get when you throw it. So that's kind of the same mana'o, but behind all these pukas. So that's why there's the pukas, but remember, it had to be a living growing reef at the same time. So there's all these structures on there, these appendages, these little circle things on the side. Those have been tested and designed to recruit corals and have corals grow. For any of us who go out in the ocean and have seen the piles of cement that the state has put out in the ocean, you actually don't see corals growing on them. And a lot of people think it's because it's cement. It's actually not because it's cement. It's because if coral grows on a flat surface like that, they get predated really quick. The uhu and stuff will just eat them, so they never get established. So part of what this team of researchers, again, not me, but my colleagues, were trying to figure out structures where the corals will recruit and grow to a size big enough where they can survive being chewed on. And that's what these little circle things are on the side. And they designed that, and there's also these plugs you can put on there. But in the end, within a few years, it'll actually be this pile of concrete will be covered with corals, sponges, and other things that will be able to grow along with sea level rise. So that's what they did. But then it kind of hit me. I was like, well, if this original, because this thing kind of looks like an emu to me, but if this original design was primarily done to decrease wave energy and be a living growing reef, I started to I wonder if we can adapt this thing to be a lobster house and a fish house while being a living growing reef. So this is where Ali comes in. in his research. So we were talking about this idea a bunch, and he got really into it. And so he started messing around with AI, and he came up with this design. Again, totally conceptual, just based on this ali'i and AI working at midnight. And he came up with this idea of something that maybe if we could adapt this design into being a fish house. So what we're thinking now is we have an opportunity to use a kind of adapted design to start restoring the reefs in Heʻeia, but we're not doing so in an effort to, have more coral reefs or anything like that. Our intention was be to help to make sure the community can feed itself and bring back some of the foods, bring back the ono of the aina that has been missing for at least 25 years in the community. And it's going to have amazing corals on it. But our primary is to make sure that the community can feed itself as good as it used to, very close to that. So anyway, I've been going out and just sharing this idea out with the community. I met with the Ko'olapoko Hawaiian Civic Club. I met with our Makai Watch program, a few other meetings here and there. And I'm really just trying to get a sense of if anybody thinks this sounds like a good idea or a bad idea. Does anybody have objections to us seeking funding to build these things? And is there anybody who has knowledge of lobster habitat that wants to help us to design a better reef? So that's all I have. And just wanted to say mahalo. And we can open it up for questions, and I can go back to any slides if people want me to go back.